Okay, so we're going to talk about today serverless. Melio is doing a lot of serverless, as you'll see, as Hadar will explain. We want to do this talk to kind of share the way that we do CI/CD in our serverless in our system. I work at Melio I've been working at Melio for about 6 years, a little bit more. I do the architecture at Melio. I'm partly to blame, or at least fully blame, that we have a serverless system. I have a team of architects in Melio. We try to be as hands-on as much as possible with the engineers, with the R&D in the company. So we kind of lead and guide the architecture. We help teams with their tech designs, and basically we have a lot of fun doing that. Hadar.
You should have shared photos of your fun day this week. So I'm Hadar, hi. I'm the Director of Platform Engineering at Melio for the past year and a half. Platform Engineering at Melio is a new department or group that contains all the infrastructure teams. It starts with DevOps, of course. Most of them are here. We are very proud to have them, and we are looking for more. We'll talk about it later. Besides that, the platform engineering team contains a few more teams. One team is a backend platform team, thank you, that is responsible for internal services and DevOps tools, along with the DevOps team. And other teams, such as data engineers, data infra. We started with the LLM. Of course, we're using Bedrock, but this is a different, maybe topic for next year. And the design system, which is UI components. It's the other side of the cycle, but it completes the full picture of infrastructure at Melio. Okay, so today we are going to talk about serverless at Melio and how we are doing the CI/CD pipeline. If you want to see the agenda and maybe run away, now is the time, or you will have to stick with us for another 40 minutes. Let's start. So what Melio is all about. I don't know if you know, but 40% of the B2B payments in the United States are still paid with checks. It doesn't happen in Israel. It might sound odd to you unless you have been working with American people, but it still exists. And this is the first problem that Melio is trying to solve, and this is how it all started. Melio is helping small and medium businesses. This is the SMB that you might see from time to time. With their payments. Each business likes to pay in different payment methods, like checks, like wire transfer, like all kinds of methods, maybe not in dollars, maybe in a foreign currency. And Melio is enabling to manage the payments however and wherever and whenever this business wants to pay. That's the main idea. I didn't introduce the most important person in this slide. This is Mel. He's our mascot, and he will escort us along this presentation. So you must know Mel. So those are the first users Melio had. They are real people, and they really use Melio system. So I talked about that, sorry. So this is how our system looks like. It's a full SaaS application. And this is how it started with our own brand, Melio.com. Then we realized we can expand and help more small businesses in the United States if we will become a platform that will serve other payment companies or banks, even in the United States, in order to help those businesses. So we have a big partnership with Capital One. I know that some of you are working with Capital One. It's one of the biggest banks in the United States, sorry. So it's the same system, same server, even the same UI, just is a different brand. And users of Capital One are logging into the bank and paying their bills via Melio. On the other side, Shopify, e-commerce platform, one of the biggest in the world, are also using Melio. When you have a shop in Shopify, you can pay your bills and manage the payments via Melio. Anyone here heard about Fiserv? Maybe yesterday. Thank you, Niv. Fiserv is a platform for payments, mostly for American banks. It's actually the back end of most of the banks in the United States. And we are now launching a partnership with them as well. So same system, different customers, different users. So as you realized already, we have one system that serves many sectors in the United States, and the users will always be small businesses, and they have regular routines. They have about tens of payments per month, and that's what they do. They pay bills, they can get paid as well, and the traffic always looks like that. You can probably understand that those are working days and this is the weekend. We have the same spikes. We know exactly what the traffic is going to be and when we need to be in high scale and when we can rest. So that's why chose serverless. I assume that if you came to this track, so you know what serverless is about, so I'm not going to explain a lot about serverless and what it gives us. But just in a high glance, you can see the reasons why we chose it. So everything here is like built in, out of the box. We don't need to worry about many aspects that in other architectures you need to worry about. So we have a built-in monitoring, we have auto-scaling, we have stability all the time. We have DevOps, we will talk about it in a second, but we have less DevOps than expected or less than the average, even in a serverless world, because AWS is taking care of a lot of things that usually DevOps are responsible for. We need to worry less about security and compliance. It doesn't mean that we don't, okay? We use the biggest systems and we have a security team, but we are covered by most of the common security practices that AWS offers. And we have continuous upgrades. We get every upgrade that AWS provide automatically. So you understood, Melio loves AWS. If you want to see some numbers, those are the resources the main resources, we have many more, that we are using in AWS in our main account. So we have approximately 1,200 Lambda, only in production, okay? Not other environments. We have 750 SQS, 180 buckets, 140 API gateways, SNS, and we do have 4 containers, okay? It is serverless. It's mostly on-prem installation of stuff or legacy code, but yeah, it still exists. Don't tell all. He created it. All of this is being handled, maintained, built by 200 engineers at Melio, and only 6 amazing, incredible DevOps that are here in the audience. I tested it with ChatGPT. This ratio doesn't exist, even in serverless world, serverless companies, and it's mostly thanks to the self-serve operations and other automations that DevOps provides, so we will talk about it in a sec. So how do they do it? When we want to create or deploy a new environment, this is under the responsibility of the DevOps. They are using Terraform to deploy a new environment that contains the common resources that each environment and every service needs, such as network definition, shared secrets, RDS that is mutual to few services together, and other things. When a developer wants to develop a new feature, he's doing it in a Lambda, and he creates his own full CDK stack. I assume everybody knows what is CDK, CloudFormation. And he's responsible for the all resources end-to-end. He defines in his repo the template YAML. He defines which resources he needs. And thanks to the enablement, enablement that the DevOps created for them, he can just run the Circle CI, we will talk about it in a second, and deploy his own stack with all the resources that he needs. If you want to know more about the self-serve operations, Shaked, raise your hand, please. She has a short session tomorrow at 11:55 in the morning. Okay, so that's like the intro. That's how we work. And now O will describe how exactly it works when you want to deploy a service.
Thank you, Hadar. Okay, I'm going to move over to here to see the next slides. Sorry. Okay, so let's talk about how we, so Hadar mentioned the DevOps teams, they do sort of like the infrastructure component of the environment, the things that are shared, the more stateful stuff that it's harder to move and to kind of deploy over and over again. And the engineers are in charge of the service structure. They're in charge of how the service is structured, that they create the CloudFormation, basically the CloudFormation template that builds the application, that serves the application. We have many services. We have a lot of queues, as Hadar mentioned. Now, we wanted to give the developers their own sort of like independent way to do the CI/CD, or at least the, let's call it the deployment pipeline. If you look up online on like what's the sort of like standard deployment pipeline of, it doesn't matter really what service you're doing, serverless, non-serverless, Kubernetes, you're probably going to see something like this. You have your source code, you build it, you create an artifact, you run a bunch of tests, and then you have a staging environment. Not everyone has, but this is sort of like a standard. You do your gating on that staging environment or a QA. You deploy to production, you monitor your deployment, and then there's a feedback loop that feeds back to the beginning, and this cycle repeats. This cycle should repeat, at least for people that want to do continuous deployment or continuous delivery, whatever they choose. Now, a bunch of these steps, or at least some of these steps, are kind of not necessarily specific to serverless, of course. You should probably do them regardless of what you're doing. Again, source code, we can give, like let's remove source code from the equation, let's remove the testing and security checks. This is something that's probably going to happen anyway. What we want to focus today is the way that we do serverless, sort of like maybe differently from other companies or from other systems. The way that we do serverless CI/CD, our pipeline, the way that it looks. Okay, so let's start with sort of like a problem or an issue or a case that we had. The icon here says Circle CI, but it's just the system that we use. It's just, it was easier to use, instead of like having a generic icon that says CI, I'm sorry, Jenkins. So we just use Circle CI here. Okay, so let's say you have your deployment pipeline. Part of it is Circle CI. You use Circle CI. If you look up online on like how to deploy serverless applications, and you go through a README or some kind of naive tutorial, you'll see commands that tell you run CDK deploy or serverless deploy or SAM deploy or any sort of like automation or infrastructure as code library that tells you you should deploy, tells you how to deploy. So you put these commands in your CI pipeline, your CI deploy step, and then this command will deploy to, let's say, a QA environment. Now you wanna advance like this sort of deployment. You deploy it to a staging environment, and then you deploy it to a production environment. Now everything's nice and fine when everything works, but then things like this, when you do it like this, it might break. Now the way it happened to us, it didn't happen specifically this way. It's just I wouldn't go into too much detail about it, but let's say the QA environment got this 1.0.31 version of some kind of important library. Now, when you run your deployment pipeline again and you do it for the staging environment, what happened to us is we got a different version running in staging and production. Now, it doesn't have to be a different version of a library. It could be just that the CI environment has changed. Maybe it progressed to a different version of, let's say, Node or Python, or maybe pip or NPM. Just something about the environment of the deployment pipeline has changed. Now, we've tried to solve this, and the way that we chose to solve this is basically having immutable deploys. So, immutable builds, sorry. So with immutable builds, it seems kind of obvious, but it really is a very important step to do this even in serverless. So instead of having a deployment step inside our CI that pushes to the environments that we need, we build our sort of CloudFormation template together with its artifacts, and we sort of tag every CloudFormation build, and we push it to a builds bucket. So we basically have a bucket, a giant bucket with many builds. Every build that kind of passes the CI steps goes to this location. We take it from there, and then we have a different, separate deploy step. It kind of pushes it to the different environments. It pushes it to QA, to staging, to production, etc. Now, this gives us a bunch of guarantees. First of all, we deploy the same thing. It's not going to change between the deploys because the environment has changed. Second, now, this is something that you're probably familiar with, like if you're going from containers, because in containers, like that's just the way to do things. You build your image, you tag it, and then you just use the tag to deploy it in different systems. But in containers, not only is like, that's sort of like a technical limitation, or this is how you should do it. In containers, it also saves a bunch of time because rebuilding a container might take minutes to rebuild. In serverless, basically, when you kind of look at the components of a Lambda function, it's just a zip file. So it's like, yeah, I'm packaging a zip file of like 20 megabytes. It takes 2 seconds, and then I can just push it. But the thing is that this is why it's important as to have immutable bids as like a core principle in your CI pipeline, to have a consistent deployment every time you run it. We'll touch upon different things regarding immutable builds. But let's say you've did your deployments with immutable builds, and now you have a bunch of environments. So we have, let's say you have your immutable builds, you deploy it to your QA environment, everything works great, and then you deploy it to your dev environment, everything works great, and now comes a requirement from the business, from let's say the product, the QA, whatever. We want to have a third environment, or a fourth, or a fifth. In Melio, we have like tens of environments. Or maybe you want to just ad hoc create an environment and then destroy it a day after. If you want to create a CI pipeline that kind of knows how to deploy to all of these environments, you suddenly need to have the CI pipeline kind of include these environments in the deploy steps, or having parameters injected into the CI pipeline that kind of know how to deploy to different environments. Now, this is very problematic because every time you sort of add a new environment, you need to go back to your CI deploy step and then modify it to know the different environments. And another thing is that not all of the environments are the same. So if we have like a new dev environment, it might not include the entire thing that lives in the QA environment, because it doesn't need to have all these, if you have like cleanup services, or maybe services that that integrate with third parties, they might not live in this sort of like dev test environment. So it means that you also need to have some kind of blueprint, or the deployment step needs to know if it deploys this service or that service to any given environment. So the way to do it is basically to try to take your deployment action into the environment itself, and not having it live inside the CI pipeline. So what we did is this. We have our builds bucket. The artifacts are being pushed from Circle CI to the builds bucket. Now, taking to the integration that, the integration behavior that AWS has, the builds bucket pushes its notifications to SNS, using S3 notifications, and now we can do something very interesting. If we take these notifications and we push them to an SQS, basically what we can create is sort of like a deploy agent that lives and gets notifications about builds that happened in the CI. So the CI doesn't need to be aware that this happens, because it happens on like the AWS side. Now what we can do is we have a deploy agent. We can just tie it. We can just tie it to the deploy environment that this deploy agent interacts with. So for example, this deploy agent deploys to QA. This is its only job. It doesn't need to do anything else. The CI pipeline doesn't even need to be aware that this deploy agent lives. So basically, it's disjoint, it's disconnected from the deployment environment itself. And then we do this rinse and repeat process for any environment that we need. We just create a new environment. DevOps kind of sets up this deploy agent with the environment. And then this deploy environment just lives with its deploy agent. So if, for example, dev lead has its deploy agent, that deploy agent knows that it needs to deploy only services like A to E, and not include service G or whatever it is. Yeah. So it makes the CI steps much simpler, because they don't really need to know which way their services go. Okay. Next one. So we did deploys to our dev environments. We've kind of controlled it. We disconnected like the development aspect, like development environments from CI pipelines. And now let's take a look at the production environment. The production environment is very different from the development environments. Although I would say we want to try to have like all the environments look this and behave the same, but it's important to say that in a production environment, sometimes the timing is what, most of the times the timing is what that matters. Not necessarily to get the code into production. Getting the code is the most important thing, but the timing is also important. You want to have proper gating in your staging environment. You want to have gating in your staging for your staging, and then if your artifact or your code passes a bunch of tests, passes security tests, then you want to deploy to production. Now, so we have this deploy agent and we want to deploy to production, but we don't want this deploy agent in this scenario to work like independently and just deploy stuff to production as soon as we built them. So we're introducing an API gateway in front of the deploy agent. Now this is very simple. The API gateway, all it does is serve a very simple API request to deploy a given service. And now the CI deploy step of production, because that's sort of like an important step in the deployment pipeline still in the CI, because it needs to know about production. It has an API gateway. It can communicate with sort of like on-demand deploy something. But now what happens, it's not necessarily an issue that happens here, but it's an opportunity that's open for us. Now we have an API gateway. We have a certain API. We have an API to deploy artifacts to a given environment. Let's say here, this is production because it's the important one. But we don't want everyone to be able to deploy all of the services everywhere all the time, because mistakes happen and you want to protect certain services, we want to protect certain assets that we have in production. Maybe we want to time limit deployments for given, in Melio, I can share that we've been under sort of like certification of certain regulatory bodies, and we had to sort of freeze deployments just to not have any risks. So what we can do, we can take advantage of API Gateway and IAM and basically set permissions on specific API actions that live in the API Gateway. So when you combine all of this, basically what you're getting is if your engineers are using IAM for their roles in your AWS account, you can limit certain roles from deploying certain services. So for example, here, in this example, only the platform team can deploy the platform app. No one else can deploy it. We can block this, and we can edit it sort of like on the fly and change this permission set. Now, this seems like a nice trick, but it has two nice features to it, or at least capabilities that we kind of benefit from. First of all, we're using IAM. And IAM, if at least the way that we look at it, if it's good for S3, that's something that sits publicly, then it's probably good for our deployment pipeline as a permission system. Secondly, it removes the entire permission, sort of like authorization worry from the deployment agent. So the deployment agent, as soon as it gets an instruction to deploy something, it needs to assume that this instruction went through some sort of permission or authorizer or whatever that is. In this case, it's the API gateway. So we basically get two things. We rely on like the capabilities and we trust IAM to do the authorization for us. And the service becomes much simpler because it doesn't need to kind of know because it just needs to follow the instructions that it got. It doesn't need to do any extra checks. Okay, so we have everything we want in our production. And it works, it's nice, and now we want to monitor it. So we have this monitor. I'm not sure actually what this measures. I just picked it up from our Datadog. Yeah, I don't know what the minutes here means, but yeah, I just grabbed it because it looks nice. No, just because it's kind of stable and it's not super spiky. It doesn't have the weekly pattern though. Okay. So this is a monitor to one of our lambdas. Now it looks nice, it looks fine. You can kind of zoom in, zoom out. You can see whatever you need to see. But we can sort of like take the way that we do the things with CloudFormation and sort of like rely and extend our monitoring system using the capabilities that we get from CloudFormation. So let's go back to our CI pipeline. We have our deploy agent. It deploys, let's say, platform app again. And then what we did, which is, it sounds obvious, but we added tags to our CloudFormation itself, to the stack of CloudFormation. Now, the deploy agent, it has a lot of context about what it's deploying. So it knows the environment, it knows the service itself is deploying, it knows the branch that it's deploying from. Again, if we go back a bit, the builds bucket contains a bunch of like metadata because this is pushed from the CI. So it knows the branch, it knows, or you can call it an alias, it doesn't have to be a branch because it's not Git anymore, it's just an artifact that lives in the repo. It knows the team. Sorry, I skipped the branch. The team was before. Yeah, it knows the branch, and then it knows the ref. Now the ref is basically, I call it a ref here, but it's just a commit ID that we use, again, from the CI pipeline to the builds bucket, and this is just the deploy agent gets the ref, so it knows which commit basically is being deployed now, or which ID is being deployed now. Now, there are a few interesting things that happen here. First of all, CloudFormation, if you tag the stack itself, CloudFormation will tag all of the resources, anything that it creates. And this is very, very comfortable because you only need to tag in one place, and then AWS takes care of the rest. And one word for a team. The team here, the team tag is very comfortable if you're trying to do FinOps, because you can just see the spend of every team in the company. But that's a topic for a different talk. So let's take the ref tag. Let's take the same graph as before, and now graph it by the ref tag. And this is the same graph as before. I just added like by ref in Datadog, if you've ever used Datadog. And now the graph is color-coded by different deployments. So again, immediately you can spot that there are a couple of problematic deploys here. And we can, if I don't have, like the mouse wouldn't work here, but because it's a screenshot, but in Datadog you can just hover over it and see the exact commit ID they created, so like this spike. But there are a couple of interesting things when you do it this way. First of all, having your different deployments appear in your monitoring system is very, very it really adds to the visibility of what you're trying, or the observability of what you're trying to do with your monitoring system. Secondly, if you've ever tried or read sort of like a practice to have your deployment appear in the monitoring system, one of the recommendations is to create sort of like vertical lines or vertical bars that shows where each deployment happened. But the problem with deployments, and this is apparent from this screenshot, is that when you deploy, it's not a single event. It's like a process. It takes time. It takes a few minutes. In our case, it takes 5 to 10 minutes for the Lambdas. And this is apparent from the screenshot itself, because if you take a closer, I know it's a bit far, but if you look at it from close to the graph, you'll see that versions always have a certain overlap period. And sometimes it can happen if you're doing a slow rollout. It can happen if you're doing connection draining, not necessarily in Lambda, maybe you have containers and you're doing connection draining, so you have a bunch of versions that live alongside each other, or any other mechanism that you might have chosen to have like different versions. And then you can actually, gives you a lot of information. And all of this basically is just with 2 simple steps. You just need to tag your CloudFormation, and then you need to have the monitoring system just aware of the tags. So CloudFormation will take care of the rest to tag all of your resources that are spun from this CloudFormation. And the monitoring system will just, you can add these tags to any kind of as a dimension to any graph that you generate. This is very comfortable. Okay, so we did our deployment, we ran our monitoring, and now this, I'm not sure what the color is, but to the right there's a spike, and we want to check what the spike is coming from. And we see that basically this is a bad deploy. So this bad deploy, we deployed the code. It caused a bunch of memory, maybe a memory overhead in the process that we weren't aware of. Maybe something broke in a configuration of the service itself. We're not sure why, but the service is malfunctioning. So going back to our sort of like immutable builds, we can take advantage of that in fixing the problem. So we have our builds bucket. This is how it looks. It's actually a real screenshot. It's not a fake one. And the dates are like 2022, 2023, 2024, but I just tried to grab some. I ordered it by time. But anyway, what's circled in red, or what's marked in red here, is the deployment that now lives in production. And this deployment is problematic. We know it's problematic, and now we want to fix it. Now, we can do a very quick sort of like rollback without running through the CI pipeline again, without doing any Git PR. We don't need to create a pull request that reverts a code change to have the CI pipeline run all over again just to bring back the old version. And we don't need to go back to the CI pipeline and look for the commit that worked and rerun the pipeline just to have it deploy again. We have an immutable build. We just go back to the commit that worked. The last commit that worked, we tell the deploy agent, take this one, deploy it, push it to production again, and within a couple of minutes, it's going to redeploy the version that was working 30 minutes ago, an hour ago, 3 hours ago, and it's going to fix the problem, or at least it's going to have less bugs, because every version has bugs. Okay, so we did all of this. We have immutable builds, and the agent sort of like stands in the center of all of this. And so we have this sort of agent, and our agent has a name. It's called Buzaglo. So if you grab any shell of any kind of, you grab a random computer, you look at the history of the shell, you'll see something like Buzaglo deploy -e production payment API. And this goes on. There are many attributes, payment API, and the commit ID. It's going to grab the relevant template from the CloudFormation, from the builds bucket. It's going to signal. The Buzaglo itself to do the deployment. So this talk is not necessarily about Buzaglo. We can grab coffee after, and I can share a lot of the things that we did with it. But just kind of to kind of give color to it. This is the high-level design of Buzaglo. It's very, very similar to the other slides that we saw. Buzaglo itself has its own stack. This stack lives in a given environment. In any environment, this stack lives there, and it's basically in charge of deploying all of the services. So Buzaglo pulls the things, the template and the resources from the builds bucket. It has its own bucket to store a bunch of things. It has a DynamoDB, step functions. It has a bunch of things to manage the sort of like the deployment. It doesn't do the actual deployment. What it mainly does is it wraps CloudFormation and makes it sort of like easier to use from a command line and a CI standpoint. Okay, so Buzaglo does a bunch of other things. Again, not about Buzaglo, but I do want to share a couple of things, a few more things that it does. Since it has a CLI and the CLI waits for the action to happen, the CI pipeline, basically the CLI waits for Buzaglo to signal that the CloudFormation deployment was successful. So the CLI basically waits, and then this triggers a successful exit code or not in the CI pipeline. So this closes the feedback loop with the CI pipeline itself. So if you merge your code into the main branch, the CI pipeline runs, it triggers the Buzaglo deploy production, and then it waits. And if it fails, you'll see it in your Git, you'll see it in your, so if you're using GitHub or GitLab or whatever, you'll see it like marked as an X. If you have Slack notifications, you'll see it there as well. So it's very nice to have this kind of loop closing on the deployment step itself of production. Buzaglo itself, for us, we have about 200 AWS accounts. Every engineer has their own account. So it knows how to deploy cross-account, cross-region. It also has, this is something unique to Buzaglo, but we needed it. It has a post-deploy hook. So the CloudFormation stack is basically sort of like a standalone service. It relies on other resources, but it's the deployment is expected to be independent and self-managed at the environment level. So, but we did need, for a bunch of services, they needed sort of like a post-deploy hook, and this happens at the service level. So in CloudFormation, if you have a Lambda function and you tag that Lambda function with a specific tag, Buzaglo will then grab it after a successful deployment and just invoke it, and then this Lambda function can do whatever. We use it to run database migrations if they're needed sometimes. We use it to signal third parties about certain things that are happening in the service. But it's very useful, and it's just a little hack that we added on top of like what CloudFormation is doing. Again, from the early slide, Fargate, Buzaglo itself also supports containers, so if it's building cross-account stuff, if you have a CloudFormation with containers inside, with containers defined, it's going to work, it's not going to break. And last but not least, Buzaglo deploys itself using Buzaglo. So when we push new code to Buzaglo, when we update it as an agent or as a library, it works the same as any other service. We push it to the builds bucket, Buzaglo sees it, and then just deploys itself using the instructions from the template. And there are many more features to come, but we can take it after if you want. So what's the different things that we think we're doing and help us to do in Melio? So your builds should be immutable. That's sort of like a base to start everything. Again, if you're not from the serverless world, if you're doing containers, this is very obvious. Probably everyone's doing that. But in serverless, it's very easy not to do it. But it's very, very important. You need to be environment agnostic. You need to try to be environment agnostic in the deployment pipeline. It's just going to help you set up more environments if you need them, if you're doing end-to-end tests, if you're doing like temporary environments, you're launching stuff and then you're destroying them. So it's going to help you very much in managing those environments. You should try to lean on, if you can, on IAM permissions. I cannot kind of stress how this is sort of helping us kind of do these. It helps us with compliance, basically, because we need to kind of protect a bunch of assets. But it's also helpful because we need to write less code. We don't need to write special code that manages permissions. And if you've ever used AWS organizations, there's a thing called SCP, which is like a policy on the entire account. So you can basically set up permissions at the account level. And even the API gateway that Buzaglo sets up for itself isn't even aware that this permission is blocked or allowed. It just does the instruction. I said it after. Sorry. The next preview's here. Okay, try to tag your resources. It's very helpful. Again, observability, when you're doing monitoring, when you're, even when you're just browsing the AWS console, if the things are tagged properly, it's just easier to look them up and figure out what the things that you're looking at are doing. For example, if you've ever reached a system that has enough lambdas in the account, you've probably had your subnet run out of IPs. I don't know, it happened to us, maybe it happened to other people. But when this happens, you suddenly realize that Elastic Network Interfaces is somewhere in between this entire serverless thing. Again, serverless there are servers there, but so you go into the Elastic Network Interfaces and then you see a giant load, a huge load of network interfaces that are not assigned to anyone, but the tags really help to figure out what to remove and what to add, and what you can, and where you need to fix maybe things that you've spun up. And if you have immutable builds, reverting a bad deployment is basically a breeze. It's just running a simple deploy command, and you're just reverting the service to a different version. Now, this list is sort of like it's not an order of importance here. There's no like specific order, it's just the orders of the slide that we saw earlier. But if I had to pick like two things that if you're not doing them today, you should be doing them, is you should use immutable builds always, although the risk there is like a high chance that your deployment will be the same. It's still a good practice to have in a serverless world. And you should always tag your resources. Try to do it. If you're going back and you don't really have that today, just add it to the pipeline today. It's going to give you a much clearer view of what's deployed. And if you have your monitoring system set up with it, it's going to make things much easier to kind of alert for and monitor. Yes, that's it. Questions?
You can repeat it. Why both Terraform for infrastructure and CDK?
Okay, I'll repeat the question. Why Terraform? It's a good question. The question that we asked ourselves. Why do we use both Terraform and CloudFormation? So if I can categorize the things that we use Terraform for and the things that we use CloudFormation for, it would be that the stateful stuff sit in Terraform and the sort of like the volatile stuff sit in CloudFormation. Now, CloudFormation is, okay, so Terraform handles state much better than CloudFormation. At least not handle state. It's much easier to manage the state that Terraform manages manually if something breaks, if some error happens, and migrate things. In CloudFormation, it's much more difficult. This is why we use the volatile stuff in CloudFormation. If there's a problem, we just destroy it and recreate it again. It's going to come back to the same point. CloudFormation, the benefit for us in the way in terms of serverless is that it's basically hosted by design. And this plays very nice into our serverless kind of policy. We don't want any server, we don't want any central orchestrator that lives outside our AWS account to do the deployments. Because it's hosted by design, issuing a command to create a stack or update a stack is just a single action on our end, and we don't need to kind of hold a network active, sort of like if you ever ran Terraform from your laptop or something, or even in a different environment that lives in the cloud, if there's a network hiccup when Terraform runs and it breaks, it loses the state, or you suddenly need to do a bunch of manual fixes. We wanted to avoid all of these things, and we wanted to kind of have the engineers work with something that they're more familiar with. So it's a bunch of things all together, but essentially the engineers are using CDK, which generates a CloudFormation template, which then goes to CloudFormation, and the DevOps team are using Terraform because it's basically better at managing the stateful resources. I hope that answers. Any other question? Oh, we're at time. But maybe we have 45 seconds. No? Yeah? If anyone has another question, just kind of. Okay. Thank you, everyone. We're also hiring.